Hey Delaney, it is Friday. We're going to go through 3-4, a little bit of it. Here's the homework assignment, so if you need to pause, there is that. But we are starting to do algebra stuff with logs, okay? And this stuff from like these next like 2 or 3 sections, this is going to be the stuff that's on the ACT. Like so much. Like what we're learning right now is like what they test you over on the ACT. It's going to raise your score like 3 points on the ACT, okay? So here you go. Properties of logs. Over here, write this. Let's talk about multiply, and let's talk about divide. Multiply, divide, okay? In log world, multiply means add, and I'll show you what that means here in a second. Divide means subtract, okay? Multiply means add, divide means subtract. So I'll give you like 4 examples. Do like a little tiny box right here, okay? All right, multiply means add, divide means subtract. Got it. Okay, let's say I have log base 2 of, let's say xy. I don't know. Log base 2 of xy. And then let's say I have log base 2 of x over y over here. Okay, let's talk about what those guys mean. So log base 2 of xy, log base 2 of x over y. All right. I'll give you a second. Here we go. Okay. Do you see how on this left side there's multiplication? What's being multiplied? X and Y. Those are being multiplied. So here's what happens. If I want to tear those apart and split them into 2 pieces, there will be 2 pieces that are both logs. Log 2, log 2. The first one is X. The second one is Y. You can put those in parentheses if you want to. You don't have to. But in between them will now be an addition sign, a plus, right? Because plus means multiply, right? So I can break them apart, and they will become plus in between them. So there's 2 logs now with X and Y, and then plus in between. Okay, what will this one look like? If I'm breaking them into 2 pieces. Log base 2 of X minus log base 2 of Y. Now, you don't necessarily have to have parentheses around those. You can around the X and the Y, it doesn't matter. Okay? So there is that. Okay? All right, now, here's what is not true. Okay, let's say I have log base 2. We'll put a base 2. Log base 2 of x plus 2. Okay? That is not the same thing as log base 2 of x times log base 2 of y. Right? X plus 2 inside, right? It has to be multiplied inside, tearing out to be add, right? So this does not work, right? Multiply does not become add. Add does not become multiply, multiply becomes add. Got it? Okay, let's say down here though, okay, we're doing condensing, okay? So this is an example of expand. Okay, both of these we were expanding into 2 groups. Now let's say we are condensing, condense, right? They will say condense this. And let's say we have log base A of 5 plus log base A of
4.
Z.
Okay.
I don't know. Oh, you can do 4. I like 4. I like 4. Yeah. How do I condense those together? Add means multiply. So log base A of 20, right? Because 5 times 4 is 20, right? So example of expanding, an example of condensing, okay? Over here, let's say I have log base A of 5 minus log base A of 4. Condense. Log base A of 5/4, or you could put 1.25, whatever, right? Okay. Now, they're going to go a little bit step further, and they're going to say, like, after we either expand or condense, then we're going to be, like, simplifying whatever we can, okay? So I'm going to skip over this guy. This is the product, right? So I did product and quotient here. This is quotient. So I did both of these bubbles at the same time and used an example. So we're going to go straight through example 1 and example 2. Write the log as a sum and simplify it if possible. So this is multiply, right? So they are basically, in a nutshell, telling me break it apart. Okay, so let's look at what this looks like. Log base 2 of what? 8 plus log base 2 of x. All right, now, I can simplify a teensy-weensy bit more, right? I cannot do anything with log base 2 of x because I don't know what x is, but I can with log base 2 of 8, okay? Let's talk about just on the side here what log base 2 of 8 means. If I'm trying to figure out what log base 2 of 8 is, I'm going to say equals x. Actually, let's say equals z, so we use something other than x, right? Okay? If I change this to an exponential function, this would say 2 to the z power equals 8. What would z be?
3.
3, right? So log base 2 of 8 is 3. This is 3 plus log base 2 of x. And now I'm done. Does that make sense? I can't do anything else with the log base 2 of x because I don't know what x is, but I can simplify log base 2 of 8, right? Okay, I just did that kind of over here off to the side. Okay, are we good with A? We break it apart. B, oh boy, look at this one. We have 3 parts, right? We have a 5 and an x and a y, right? Okay, so what's this look like? ln 5 plus ln x plus ln y. Okay? Can we simplify any more than that? Assume that x and y represent real numbers. Okay, what? Log base e of 5, but then, okay, so if I write this guy, don't write this down. So this would be log base e of 5, right? And if I say equals z, this would be e to the z power equals 5, right? And like he's going to be a decimal. Let's just type this into our calculator, right? Because he doesn't come out nicely, right? Like 2 to the 3rd power is 8. That came out nice. This one, let's just do our calculator. ln of 5. 4 decimal places.
1.6094.
Okay, 1.6094 plus ln x plus ln y. There you go. He is expanded, and we have solved all of the pieces that are able to be solved, right? We can do ln of 5. Okay, good? Yeah. All right, now this is quotient, which means we're going to be dividing. So let's do this guy here. Write the log as a difference and simplify if possible. All right, this guy. I only have 2 pieces, right? Log base 3 of c minus log base 3 of d. Can I switch those around and put the d first and then the c next? No, the c is on top. He has to go before the minus, right? Okay. Can I simplify? No, because none of those are numbers. So that is it. I'm expanding and I'm done. C and D are not numbers. We don't know what they are, so we just leave them like that. That's done. Yeah? Are we good with this? Okay. This guy, here we go. Log of what? X minus log of
Oh, I was thinking
1,000, right? Okay, can we simplify any of those? Log of 1,000. Okay, so let's talk about over here. I'm going to do log of 1,000. Log base what? 10 of 1,000, all right? And let's say equals z. We'll use a number other than x. So this is saying 10 to the z power equals 1,000. And z is 3. So what will this look like then? Log x minus 3, because that's what log of 1,000 is. Yeah? Okay? Beautiful, beautiful. Okay, now this. Well, let's do power of power, and then we'll stop. What time do we get out of here? Soon? You're crazy. 50? We get out of 54? Gosh, we have lots of time. Okay, we'll do power of power. Okay, we'll do power of power. Okay, all right, this one I like. I love this one. So here we go. Let's say this. Ready? Let's say we have log base. I'll just use log base like 2 of 10 to the 3rd power. Okay? All right, write this down off to the side over here. Log base 2 of 10 to the 3rd power. Actually, let's go log base 2 of x to the 3rd power. Whatever. Doesn't matter. It could be 10, it could be 3, it could be whatever. Log base 2 of x to the 3rd power. So like this is stuff is inside of log, right? What does x to the 3rd power mean? X times x times x, okay? So that's what this is, right? Is x times x times x, right? Got it? Okay, that's what that means, okay? But we know that multiply means add. So I can break this into 3 pieces, and it is log base 2 of x plus log base 2 of x plus log base 2 of x, right? If I take log base 2 of x plus log base 2 of x plus log base 2 of x, what will that give me?
log base x
3 log base.
3 log base 2s of x, right? There's 3 of them, right? Okay, so because of the properties of logs and how they come out to be, this guy means that I am able to simplify by taking any exponents and moving them down in front of a log, right?
5.
Like that is legal because that's like, this is the proof of that, right? Because multiply means add and all the things, right? Now, it's not true if there's no log there. For example, like if I have x to the 3rd power and no log in front, that's not the same thing as 3x, right? Like we know that, right? Like you can't just move the 3 down in front of anything willy-nilly, right? There has to be a log in front, right? Because that's how logs operate. That is the power of powers. So this says right here, log base b of x to the p power. You can move the p down in front and the p goes here, right? That's what it says. Okay. So here we go. Apply the power property of logs. Ooh.
1/5.
Don't do it unless you
No.
No? Oh. -5.
Okay, this is ln. He is x squared underneath of here, right? Okay, so this 5th root is your right to the 1/5 power, right? Right? The 5th root means to the 1/5 power. Do we know that? The square root means to the 1/2 power cubic root. Okay, but what does this make right here?
4.
X to the,
I only do it when I'm down.
if I multiply the 2 and the 1/5 together, that would be 2/5. Okay, now I'm going to bump that thing down in front because ln is the same thing as log, right? ln is just log e. So I could bump that down in front. So what will he look like?
2/5 ln.
2/5 ln x, right? I would much rather deal with ln of x than the 2/5 in there as well, right? As an exponent. Gross. Okay, there's that. Got it? What is this guy?
2 log x.
2 log x. Right? Not so bad. The 2 can come down in front.
Yeah, that makes sense.
Only because there's a log there. All right, you should be able to
It's a problem.
get to, I don't know, how far?
It's cricket stuff.
Everything up to write a log expression in expanded form. Write a log expression in expanded form. Hold on. I'm going to steal your book. Properties of logs. Write a log expression in expanded form. Up through 24. Does that even give you anything? Oh, hey, right here. Okay. Yeah, almost half. Yeah, exactly half, actually. So, first 5. You can do the first 5. There you go. Okay. Beautiful. Like it a lot. All right, goodbye.
Would